Okay, so we want to solve a second order linear non-homogeneous equation here with constant coefficients. We just have constants here, but we don't have a zero over here. So according to what we did in the previous video, we need to first of all solve the homogeneous equation, which we do just as we've done. So I'm assuming the answer looks like y equals e to the RT. Plug that in, we end up with this quadratic equation that we need to solve. Anyway, I got factors here, and I get that r equals 2 or r equals -5, which tells me that the general solution of the homogeneous equation looks like this. I'll call it y sub h, being h standing for high or homogeneous. So C1 times my first solution, e to the 2t, and C2 times my second solution, e to the -5t. So now, having done that, I can describe all the solutions to the non-homogeneous equation by just finding one. And the question is, how do you find the one? Well, we're going to describe a couple different ways. One of them in section 3.5 is what's called the method of undetermined coefficients. In section 3.6, we'll come back and look at a different way, which is called the method of variation of parameters. Okay. Now, the method of undetermined coefficients, I think, is the easier of the two to do, but it only works in some very special cases. And these are cases where the stuff on the right-hand side of the equation here are really nice functions that you can kind of guess what kind of solution should look like. You know, I'm looking for a function y that when I multiply by 10, and I take its derivative, multiply that by 3, and take its second derivative, and combine them all together, I'm going to get something that looks like 13e to the t. So, you know, what kind of function combines with its derivative and the second derivative and end up looking like, you know, an e to the t? Well, I'm guessing e to the t. And this is the thing, with the method of undetermined coefficients, there's going to be certain types of functions, exponential functions, polynomial functions, and sums of sines and cosines. If you have one of those things over here, then, or a combination of those things, then we're going to be able to use this method. Otherwise, we're going to have to do something else, unless you're really good at guessing. So I'm looking at this thing right here, and I'm thinking, I'm going to guess something times e to the t. So I'll call it a times e to the t. And here is my undetermined coefficient. I don't know what the a is. I don't even know this is going to work, but I suspect it will. At least it has a chance of working. So, you know, I'm going to plug it in. So I take the derivative and the second derivative, and I plug it into the left-hand side. So there's the second derivative plus 3 times the first derivative minus 10 times the function, and I need that equal to 13e to the t. Well, if I could just find a, it would be great. If there is no solution that looks like this, then something will happen in trying to solve here, and it'll tell me that, you know, 0 equals 1, or a equals the square root of -15, or something like that, where it's not going to give me a real function. But what happens is nice, because as I combine the side over here, I've got 1, 4 minus 10, so -6a times e to the t on this side has got to be equal to 13e to the t on that side. So -6a has got to equal 13, and a is 13 over -6. So what I've done is I've showed that y equals 13 over -6 times e to the t is a solution to the non-homogeneous equation. That's all I need. I need one solution. And so I've got it right there, and I add on all of the solutions to the homogeneous equation, and I'm describing all of the solutions to the non-homogeneous equation. So how did I get this? I looked at the stuff on the right-hand side and said, I wonder what kind of function would work like that. Well, this is an exponential. Let me try an exponential. And hey, it worked. All right. So let's try another one here. Here is y prime plus 3. Do I have the same left-hand side? Is that the same left-hand side as the previous one? It is. All right. So the left-hand side is the same as the previous example, but on the right-hand side, I've got this quadratic function now. So I'm looking at it saying, well, first of all, I got to find the general solution to the homogeneous equation, which of course is the same as the last example. So I've got it already right there. And now I'm looking at it saying, what kind of function combined with its derivative and its second derivative will give me a quadratic polynomial? It's like, well, how about a quadratic polynomial? because its first derivative would be linear, its second derivative would be constant. If you add and subtract all those kinds of things together, you're going to end up with this quadratic. Okay. But the general quadratic has three coefficients, at squared plus bt plus c. There's three coefficients there that I don't know. They are undetermined, hence the name undetermined coefficients. I need to determine those coefficients. So here we go. I'm going to take my function, my derivative, and my second derivative, plug it into the left-hand side there. So the function, the derivative, the second derivative, plug it in the left-hand side, and I need that equal to the right-hand side, t squared plus 4. So, all right, we're going to multiply some things out here, distribute the 3 through, distribute the negative 10 through, and what do I get? I get, okay, yeah, then collect some like terms. So everything that's got a t squared in it goes over here. Everything that's got a t in it, right here, there's a 6a and there's a negative 10b, so those are right there. And then everything that doesn't have a t in it, so my constants are 2a, 3b, negative 10c. Those are all right here. So this polynomial in t on the left-hand side has to equal that polynomial in t on the right-hand side. There's all sorts of ways you could proceed here. Right? Since this is a function equaling a function, you could plug in different values for t to try to get some relationships here. Or you could, and this is the method that's quite often used, you say, hey, the coefficients of the polynomial on the left-hand side have to match the coefficients on the right-hand side. So in particular, this negative 10a, which is the coefficient of t squared over here, has to equal this 1, which is the coefficient of the t squared over there. So I've got this equation. Likewise, I've got 6a minus 10b has got to equal 0 because the coefficient in front of the t on this side is 0. So I've got this equation there. And the constant term here, 2a plus 3b minus 10c, has got to equal the constant term over there, 4. So I've got these three equations in a, b, and c. Solve them. Solve them however you see fit. Well, this is kind of nice because this first one only has an a in it. Tells me that solve for a is 1 over 10. I can then plug that into here. So I've got 6 times. So what do? I plug in a negative 1 over 10 here and solve for b. So I've got, there's a negative. How does this work? I think I've got a minus sign wrong here because I put a negative in there. I bring it over. Negative. Hang on, pause. No, I think I'm good. So what I do is I pull the 10b over to this side, and so the a is being plugged in, so I got a negative 6 over 10, and then I'm dividing by 10 to get a negative 6 over 100. So that's what b is, and now that you know a and b, you can solve for c, and it's just a matter of plugging it in, and I've got just barely off the screen here. Can I slide that over? Can I slide that over? It doesn't want to slide over. Can I slide the screen over? I can. There we go. Negative 219 over 500. And so my particular solution is not particularly pretty. Well, I guess, beauty is in the eye of the beholder. So this is really beautiful solution of negative 1/10 t squared minus 3 over 50t minus this 219 over 500. That is a solution to the non-homogeneous differential equation. So the general solution for all of the solutions to the non-homogeneous equation will look like this. They look like this particular solution plus the general solution for the homogeneous equation. Okay. One more, is that what I'm doing? Yes, here we go. I'm going to do one more. Oh, and I'm going to run out of stuff. Here we go. That's right. This was the stuff written down here. Was what I did in class last year, and time must have run out. So we're going to leave you hanging on this one too. Actually, what happens is this: you've got this same left-hand side as we had before. Now I got to equal to 4e to the 2t. And I said, oh, this is just like the first one I did. So I'm going to try ae to the 2t, and I get the derivative and the second derivative, and I plug it in, and I get this plus this plus this plus this, and all the a's go away, and so I get 0 equals 4e to the 2t, which is clearly false. Clearly false. That means there is no a that's going to make this a solution to that equation. It is not just, it's not going to work. What happened? Well, what happened is this e to the 2t is actually part of the homogeneous solution to the homogeneous equation. So multiplying by a isn't ever going to make this left-hand side turn into a 4t because because anything that's a constant times e to the 2t is part of the homogeneous solution, so you're going to get a 0 out every time, right? Just like you did, you got a 0. It's not going to equal that over there. So the thing is, this is not the solution. And this happens once in a while when the stuff on the right-hand side is part of what already is the solution to the homogeneous equation. Okay, then you got to do something else. Well, now it's a matter of what do you try? And I hate to say, well, hey, try this. Try t e to the 2t. No, it turns out it works. But it's like, well, I just remember that. It's like, I don't know. So what I really am going to say at this point is, well, this would be a good reason why we might need another method for solving for this particular solution. If the method we have doesn't work, then let's come up with another method. So that will be, for tomorrow, we will use the method of, no, this is undetermined coefficients. We're going to use the method of variation of parameters to come up with that fact that you got to multiply by t without just guessing it. It's just phenomenal to me that anyone could actually guess it. Anyway, but try it, plug it in, see that it actually it does work. Right. Anyway, yeah, you should be trying some problems in section 3.4. It's 3.5 today, yeah, and then 3.5. If you've got questions, you can post them down below in the comments. Just respond to this comment, and or bring them to class tomorrow. I assume we will have class tomorrow.